We're now moving on to the next one. So this is our third example, and it's double displacement. And double displacement was an example I've actually talked about. Double displacement, also called double replacement. The general form is that again we're going to see here that the actually anion is the X and the Y will trade places with the cations A and B in the situation. So we have two ionic compounds and they're literally changing places. In with this comes our first exposure to solubility rules. I'm going to expand on these rules right now, just expand or just memorize these first ones. First of all alkali metal compounds are soluble. That's anything in group 1. All group 1 are soluble. Ammonium is soluble. All compounds containing nitrate are soluble. So nitrates are soluble. Most hydroxide compounds are insoluble. Alkali metals bound to hydroxides, like sodium hydroxide is an exception. And most chlorides, bromides, and iodides are soluble except when there was silver, mercury 1, or lead 2. So again, we have to know these, memorize them as we go forward, because now you're going to have to know states of matter. So here we go. I have HCl, hydrochloric acid, and sodium hydroxide. Both are aqueous. It's a strong acid, strong base. And so what's going to happen, they're going to trade places. So my H plus, OH minus come together and form water. My sodium and chloride come together and form sodium chloride. If I were to strip this down to the ionic, in which I will ask you to do, hydrogen breaks down to +1, chloride's a -1, sodium's a +1, hydroxide's a -1. If we pause right here, this is where you can see how the double displacement took place. The hydrogen joined up with hydroxide forming H2O, and the sodium joined up with the chloride forming NaCl. Water, by default, is a liquid. That's just, again, default. Just like your hot sprinkles. Whenever I say water, default is liquid. Liquid will not break down, but my ionic compounds, my aqueous, will break down to the ions. So now what I'm going to do is I'm going to talk about my net ionic, meaning I'm going to get rid of the spectators. What ions show up on both sides? And as you take a look, you realize, oh, that's sodium chloride. So sodium chloride, if I get rid of them, those little terminology are called spectator ions. Those are going to come back with acids and bases, spectator ions. So really, all that's happening here in this reaction, I have H plus OH gives me water. H plus biology, strong acid. OH minus hydroxide is a strong base, forms water. This is called a neutralization reaction. This is a strong acid, strong base. Next example, silver nitrate, barium chloride. The nitrate, -1, is going to leave the silver and join up with the barium. So I'm going to need 2 of them to zero out my barium. The chloride, -1, is going to join up with silver, come 1 to 1. Remember, never worry about subscripts here. We're just stripping them down and rearranging them again. The ionic, we have Ag plus, and my nitrate, NO3-, 1 to 1 ratio. My nitrate formed the barium 2+, that's why I needed 2 of them to zero it out. As I look at this, and stripped it down to the ionic, again, my silver chloride, I had to know, back to the spectator, back to the solubility rules, chloride, bromide, and iodide are normally soluble except with silver, mercury 1, and lead 2. So those are very, very important you know. So brown over the silver chloride is a very common one you'll see in a lot of problem solving. The silver chloride falls out as a precipitate. So it forms a solid, falls out of solution as a precipitate. So if I get rid of my net ionic, I have 2 silvers, or actually I have 2 nitrates and 2 bariums. So what I get, my net ionic, I actually have 2 silvers plus 2 chlorides, gives me 2 silver chlorides, so I reduce it down to a 1 to 1 to 1 ratio. Barium and nitrate are my spectators. Spectators mean they had nothing to really do with the reaction. They were just carriers. They were just Uber drivers. Next one, Fe3-. So iron 3, right? So iron 3, chloride's -1, potassium +1, hydroxide's a -1. So my hydroxide is going to join up with the iron. I'm going to need 3 of them. And my potassium and chloride are going to come together in a 1 to 1 ratio. And again, that's just all nomenclature. You kind of know your nomenclature. So in this situation, then we balance it. Now I'm going to strip it down. So I have iron 3+. I have 3 chlorides. Each coming as a -1. I have 3 potassiums +1. I have 3 hydroxides -1. My ferric hydroxide actually falls out as a precipitate. In the salt, hydroxides are soluble except with alkalis. And then I have potassium and my chloride. So my aqueous stripped down to the ionic. I get rid of my spectators, the cation and anion that show up on both sides, and it will be equally the same on both sides. And I'm left with iron 3 plus ferric hydroxides yields ferric hydroxide. Again, chloride and potassium are your spectators. The next one, lead 2 chlorate plus ammonium chloride. So my chloride minus 1 is going to join up with my lead 2. I made 2 of them. My chlorate and ammonium are going to come together as a 1-to-1 ratio. I know my lead 2 chloride, bromide, chloride, and iodide are normally soluble except with silver, lead 2, and mercury 1. And so this lead 2 actually pulls out a precipitate. It's insoluble. My aqueous gets stripped back down after I balance it. I have 1 lead 2. I have 1 plumbus. I have 2 chlorates. I have 2 ammoniums, 2 chlorides, a lead 2 chloride. I have a 2 ammonium and 2 chlorates on their side. So my ammonium and chlorates are both the same on both sides. They are my spectators. Get rid of them, bring everything else straight down, and I have my net ionic. Now, the double displacement stands out because the 2 compounds on your reactant side are ionic compounds. Water is not an ionic compound. So don't try, remember that one, metal oxide plus water? Don't think of double displacement. Water is not an ionic compound. So again, double displacement stands out because the 2 reactants on the reactant side are ionic compounds. And the anions just trade places. Calcium acetate, ammonium carbonate. Carbonate minus 2 joins up with calcium plus 2 is a 1-to-1 ratio. Ammonium plus 1 and acetate come together in 1-to-1 ratio. I balance it. Then I strip it down. Calcium, acetate, aqueous, I strip it down. Ammonium carbonate, aqueous, I strip it down. Calcium carbonate stays together as a precipitate. And ammonium acetate strips down. I realize that the acetates and my ammoniums are my spectators. Bring everything else straight down. There's my net ionic. And there are your spectators.